Guys, my name is Mr. Lead, and today we're going to be looking at energy. Now, when we talk about energy, you probably have some ideas in mind about what energy is. You might think, oh, energy, that's the thing that you get from the food you eat, or that's the thing that you see running through the wires to produce the light that's up in the ceilings. But what you might not understand is that energy can actually be found in so many different forms than that. Energy is actually all around us. And as we start to unpack what energy is, you'll understand how energy really is all around us. So, first thing to understand, there are two forms of energy. There is potential energy or stored energy, and then there's energy that's being carried out, or energy in motion. That's kinetic energy. So let's start to unpack both of these forms. First form, we'll look at energy that's being carried out. The first type of energy is mechanical energy. That's the energy that you're seeing in movement. So when you are moving your arm, that's a type of energy. That's a type of energy that you're exerting. That's you're using. When you see a bicycle that's pedaling, that's energy. That's mechanical energy. That's energy that's being carried out. Heat energy. That's another type of energy. Remember, this is energy that is being carried out. Whenever you see a fire, or whenever you see an object warming up, you're seeing energy being dispersed throughout that object, or you're seeing energy being released in the form of fire. Energy can also be in the form of light. Light is a type of energy. So the light that is streaming down from the light bulbs on the ceiling is a type of energy, just like the light that is coming out from the sun. Now, light is actually a type, a subcategory of a broader type of energy called electromagnetic energy. We're going to look into that a bit later, and we're going to look into light energy in a lot more depth later as well. Sound energy, that is when you're seeing energy in objects that are vibrating. Basically, whenever you hear sound, you're hearing vibrations. This could be the air vibrating, or it could be an object vibrating. The sound energy comes in the form of vibrations traveling through objects. And the last type of energy that is being exerted that can be exerted is electrical energy. That is energy that is seen when you see electrons that are moving from one surface to another. Remember, electrons are the subatomic particle in atoms. Those electrons can actually leave one atom to join another, and they can leave that atom to join another, and they can just keep moving on as though they're moving down a wire, and that's how wires work. In wires, you see electrons streaming down. So if you're still trying to understand what exactly is energy, maybe think of it this way. Energy is basically the display of change. When you see a change, you are seeing energy take place. Whether that's you're seeing something move, so that's mechanical energy. You're seeing a change. Well, where you see a fire exerting heat and light energy, you're seeing some sort of change happen. So here's some more examples of how energy can be witnessed. In these simple machines, like a wedge and gears, you see mechanical energy being used. In electrical energy gets used in a lot of appliances. Light energy gets used. We see light energy not only being exerted by the sun, but by light bulbs, as said before. Thermal energy comes from, say, fire, but it can also be just in the heat around us. That is thermal energy. And also sound energy. That can be found. That can be exhibited in musical instruments or the likes of. Now, I mentioned earlier that there are two forms of energy: potential energy and kinetic energy, and that's true. There are. But what you've got to understand is a bit of terminology here. The word kinetic energy doesn't necessarily only refer to these 5 types of energy. Kinetic energy can also be more specifically referring to mechanical energy. So when someone says there is kinetic energy here, they could be talking about thermal energy or sound energy or light energy, or they could be saying, when they're saying there's kinetic energy, they're talking exclusively about mechanical energy, because kinetic energy is actually interchangeable with mechanical energy. So in terms of terminology, you just understand kinetic energy can refer to all of these types of energy. It can be an umbrella term, or it can be referring to only mechanical energy. The way the Pearson Science textbook uses the term kinetic energy, it doesn't even mention mechanical energy. It will only ever say kinetic energy. So basically, the term kinetic energy isn't even used as an umbrella term in the Pearson Science textbook. We only see kinetic energy as in reference to mechanical energy. So that's what we'll probably say from here on. We'll say when we're talking about kinetic energy, it's mechanical energy. All right, cool. Terminology out of the way. The second type of energy is stored energy, also known as potential energy. Now, when I've got this rubber band here and I release it, you're observing kinetic energy, mechanical energy, whatever you want to call it. But before I release it, you know that as soon as I release it, you're going to see energy. While it's being stretched and ready to be released, it has what's known as potential energy. That is energy that is not currently in use. So when it's being pulled out, you can see potential energy. It has the potential to exhibit energy. When it's released, that's kinetic energy. Other types of potential energy, and that was an example of elastic potential energy, but other types include chemical energy. This is energy that you see in your food. Your apple there is not exerting heat or light or electricity or even mechanical energy or anything. But once you eat your apple, you are going to be able to convert and break apart the chemical bonds to gain energy from that. So chemical energy is a type of potential energy. Gravitational potential energy, that's another type of potential energy. Basically, every object in existence will have some sort of gravitational potential energy depending on its mass. So this water bottle here, as soon as I drop it, you'll see it exerting energy to fall towards the ground. But before I drop it, it's ready and raring to go. It's ready to fall towards the earth. It's holding gravitational potential energy. Okay, and the last type of energy, potential energy anyway, is nuclear energy. Nuclear energy is the energy that is stored inside atoms or inside particles. So inside the nucleus of an atom, if you were to split a nucleus apart, you would actually see lots and lots of energy exert, even though an atom is microscopically tiny. If you split it apart, you see energy come out. This is actually how atomic bombs work. An atomic bomb works by splitting apart really big and heavy atoms and exerting lots of energy. So yeah, nuclear energy is a type of potential energy because before you split that atom apart, and while that atom is a whole, it has energy in it, as per Einstein's equation, and that energy is equal to the mass of that atom times the speed of light squared. So those are the 4 different types of energy, stored energy, that is. We've got gravitational energy, chemical energy, strain energy, which is actually just elastic potential energy. You're going to need to understand that some terminology can be interchangeable here in this topic. And then there's also nuclear energy, so the energy stored within atoms. Now, what you got to understand about energy is that energy cannot be created nor destroyed. It's only ever transferred. What I mean by this is one object can give energy to another object, but one object cannot create energy for itself. So let's look at heat as an example. Heat can be seen. Heat can be transferred in three different ways. You can have heat being conducted, just like we've talked about how metals are good conductors of heat. You can see heat being transferred alongside metal or other objects. Heat can also be convected. This is where heat is transferred through gas or liquid. It usually spins around and rises. Hot air rises. And heat can also be radiated, where it's heat energy is just spreading outwards from the source. Here's a better way to understand these three types of heat transfer. Here's conduction across. Conduction is observed across the handle. Convection you see inside the liquid, and radiation you're seeing spread outwards from the fire. Now remember that this heat energy that's being spread out is never actually, you're not seeing that heat energy disappearing, okay? It's not being destroyed. It's only being lost and spread out, okay? Likewise, this heat energy came from somewhere else. It had to be transformed from somewhere else. It wasn't created. It didn't spark out of nowhere, okay? In fact, when you see an object that is cold, that is just an object that has an absence of heat, all right? So heat and like all other types of energy is always transformed. You can see plants will transform light energy into chemical energy that they store, or electrical energy is transferred into thermal energy in most of our appliances. We transform our stored chemical energy into mechanical energy when we move, and most machines also do the exact same thing. The energy that we're getting when we move is not energy we're springing out of nowhere. That's energy we had to get from a previous object. Okay, so energy is never ever created nor destroyed. It's only ever transferred from one thing to another. All right, that's how the first law of thermodynamics works. Last thing to know about energy: how do we measure energy? Well, there's actually a few different ways we can measure energy, but energy is always calculated and measured in joules. And if you're in America and you're talking about food, you can talk about energy being calculated in calories. But here in Australia, we calculate our food energy in joules as well. So joules is a measurement of how much energy things have, and just like other forms of measurement in the metric system, you can have kilojoules, which is 1,000 of a joule. You have megajoules. You got just normal joules and as well that can be calculated into megajoules. So here's some conversion rates. A kilojoule is 1,000 joules. A megajoule is 1,000,000 joules. And here's how you would calculate these two megajoules back into these joules into megajoules. Okay, so that is energy. Thanks for watching.